In the previous videos, we discussed how breeding values can be estimated. But how accurate are estimated breeding values? Or in other words, how close is the estimated breeding value to the true breeding value? If the estimated breeding value is inaccurate, we may select the wrong animals as parents for the next generation. In this video, I will explain the accuracy of estimated breeding values and how it can be calculated. So the first question is, how can we measure the accuracy of estimated breeding values? This figure shows that the estimated breeding values deviate from the true breeding values, the so-called prediction errors. To measure how close the estimated breeding values are to the true breeding values, we can use the correlation between estimated and true breeding values. This correlation is called the accuracy and denoted as RIH. The accuracy can vary between 0 and 1. In these two examples, the accuracy is 0.51 in the left figure and 0.95 in the right figure. In other words, the breeding values are more accurate in the right figure than in the left figure. However, these figures assume that we know the true breeding value of an animal, while in real life we cannot measure the true breeding value of each animal. Fortunately, we can mathematically derive the accuracy of estimated breeding values. For instance, in the case of home performance, like milk production of this cow, we can derive that the accuracy is equal to the square root of the herdability. So the accuracy is higher when the herdability is higher. In this table, you find equations to calculate the accuracy for a number of situations: on performance, information of parents or grandparents, and information of full sips, half sips, or progeny. Let's have a closer look at two examples. The first example is the case that we want to calculate the accuracy of a rooster based on his paternal half-sisters or half-sips. The equation contains three variables: the number of half-sips, the herdability, and the ratio of the common environmental variance to the phenotypic variance. And this figure shows that the accuracy increases with the number of half-sips and with a higher herdability. In this case, the maximum accuracy is a half, because we only get information about the breeding value of the sire of this rooster, and we do not have any information about his dam and his own Mendelian sampling term. The second example is the case when we want to calculate the accuracy of the breeding value of this Hereford bull for weaning weight based on his progeny. This equation contains only two variables: the number of progeny and the herdability. And this figure shows that the accuracy increases when the number of progeny increases and when the herdability is higher. Furthermore, we see that the maximum accuracy is approaching 1 if we have many progeny, because we get full information about the breeding value of this bull. So in summary, the accuracy is the correlation between the estimated and the true breeding values. The accuracy increases with the herdability and with the amount of information available, and we now have a set of equations to calculate the accuracy of estimated breeding values in a number of situations. And these equations can be used to design and optimize your breeding program.